This week, a small Chinese company spent just $6 million to build an AI model that wiped out $1 trillion of market value on the US stock market. And 600 billion of that trillion came from just one stock, Nvidia. Not only that, but this model matches the performance of state-of-the-art models that companies like OpenAI have spent hundreds of millions of dollars to train. And the craziest part is that this was just a side hustle from a quant trading company that basically had some spare lying around GPUs and decided to build it. In this video, you're going to understand the revolutionary breakthrough that DeepSeek just open sourced to the world, why everyone, including Wall Street, have completely misunderstood the implications of DeepSeek, and what this actually means for the future of AI, and it might not be what you think. The real story behind DeepSeek is actually more interesting than the headlines will let you believe, and let me show you why. For those of you who are new to the channel, my name is Alfie. I'm the co-founder and CEO of Toolflow AI. We're a startup that specialize in building AI agents. On our platform, you can actually build your own agents and automations without a single line of code. And if you'd rather have experts handle it, you can actually hire us with our agency and we'll build them for you. Not only do we have our platform, but we also offer educational workshops for your employees to help them upskill in everything AI. So if you're interested in transforming your business for the era of AI, then click on the link in the description below and book a call with our team. Now, with that being said, let's get into the video. So let's start with how AI models are typically built, because this is crucial in understanding why DeepSeek was so revolutionary. So think about how a human learns. We read, we take in information, we have articles, we then act, we get some feedback from our friends, our teachers, our colleagues. Now, machines are basically doing this same thing, but they're doing it at a massive scale. First, these models need to process enormous amounts of data. Think of all of the content that's on the internet. Think of additional articles that you might have read. Think about all of the information, all of the transcripts that are in YouTube videos and so on and so forth. There is just enormous amounts of data. And this requires huge data centers, which are filled with things called GPUs. You can think of these GPUs like powerful calculators, except they cost about $30,000 each. Now, big companies like OpenAI and Google are using tens of thousands of these GPUs just to train one large language model. So you can see how the costs can really add up. But processing all this data is just the first step. These companies hire thousands of people and they call them labelers. And they're basically looking at the responses from these language models and then labeling the responses. Was it good? Was it a safe answer? Did it correctly get to the point that the user was looking for? Now, this is obviously subjective, and to scale this kind of training requires a lot of people, which in turn costs a lot of money. This feedback is basically called reinforcement learning, or RL. And this is really important for the models to learn what good looks like. And this is a very important point because DeepSeek effectively does something different. Now, the traditional approach has led to some very impressive results, but it's incredibly expensive. As I said, OpenAI has spent hundreds of millions of dollars training AI models. We have companies like Microsoft who are coming out saying that they're going to spend $80 billion every single year on AI infrastructure. Now, this is where DeepSeek did something revolutionary. Instead of using humans to judge the outputs and subjectively say whether they were good or not, they created an objective way to say whether the task was completed correctly. So think of the difference between writing a story. It's very difficult and subjective to say whether this was a good story or not. But if you have a math problem and say 2 + 2 = 4, it's very objective to say that that math output is correct or not. So DeepSeek revolved their entire training method around this insight, effectively trying to find ways to objectively say whether this was a good or bad output. Now, doing this without human involvement allows you to scale that up to massive proportions and at a much cheaper cost. Now, what's really interesting is you'd think that this would only work for things that are objectively true or false, like math problems or engineering problems. But they found that this same kind of method, when it could train itself, actually worked very well for creative things like creative writing and things that are more subjective. Now, this approach has two major advantages. The first is obviously there's no need for thousands of human labelers, so that reduces a massive labor cost, so it makes it a lot cheaper. But because we now don't need the human labelers, the second advantage is you can now scale up the number of things that you can test. And when you do more tests, you get more accuracy and you get a much more powerful model. Both of these combined led to really cheaper results, but also more effective models. The end result being that they spent $6 million to produce a model that matches the same performance capabilities that these companies spend hundreds of millions of dollars producing. Now, that is absolutely crazy, but also has completely shook up the industry. Now, DeepSeek didn't just revolutionize the way they train the model, but they also revolutionized the way it calculates stuff at the time that you run it. You see, the typical way that these models answer a question is they use all of their kind of computing model power in the same go. It's almost like you ring up a call support center, and to answer that one question, everybody in that call support center is there focusing on answering that question. So it's a massive waste of resources. That's clearly inefficient, and there would be a much better way to have a few experts that are in that call center that would then be called upon every time you had a very specific question. And that's exactly what DeepSeek did. They found a method which they called the mixture of experts. And basically it allows you to use only a percentage of that model's capability to answer any one question. So instead of using 100% of the model and that kind of compute power at runtime, and at runtime basically just means when you ask the model a query, it can now use perhaps 5% of it and have these very specific experts. And again, that not only means that they've massively reduced the cost to train the model, but now they also massively reduce the cost to run the model when someone is actually putting in a query. And they call this inference or at runtime. So the inference is because you're inferring what the next words are, and at runtime is just basically when someone's using it. But every time, you have to use lots of computers to train the model in the beginning, but also it costs money to actually run the model, and they've massively reduced that too. And that's not the only revolution. They also changed the way they handle language. Now, traditionally, these language models are kind of prediction models. They're predicting what the next word should be. And so when they do this, they're doing this one word at a time. So if you think of a sentence like the cat in the hat, it's thinking of that exact next word. But if you're thinking about an entire phrase that should come after it and be like knock knock, you know it's going to be who's there is kind of the who's there is maybe a phrase. But actually they're thinking who's and then there. And that's kind of the more traditional way of doing it. And so again, this is like one word at a time. Now, DeepSeek figured out a way to basically infer what the next phrase would be. And so instead of doing this one word at a time, they could bundle this up into a sentence. Now, they call this multi-token prediction. And again, it means that there's less compute for every time a word or a next thing has to be predicted. Now, this last breakthrough might sound a little bit technical, but it's actually very, very simple. Behind each calculation, there's a bunch of math. And to do this, they're using really accurate numbers, a certain number of decimal places. And basically they use this thing called FP8 training, which reduces the number of decimal places. It's almost like rounding the number up to a smaller amount to be able to do the calculations. They kind of figured out they didn't need to have that level of accuracy. And so you can think of this like trying to measure the distance from London to New York. You don't need to do that in inches or millimeters. You do that in miles or kilometers. You don't need the millimeter level of accuracy. So again, when you have this reduced compute necessity, it brings down the cost. Okay, so let's summarize these innovations. Number one, you no longer need enormous data centers. Number two, you no longer need thousands of human labelers. Number three, the model is actually 95% more efficient because of the smaller experts that are used to answer the queries. So we're basically not using all of the model's capabilities in every single query. Number four, it can predict entire sentences instead of just one word at the time, again, making it cheaper. And number five, it's using much more efficient math to calculate the answers. The combined result of these innovations is that the model costs 90% less than their traditional counterparts. Not only that, but the model can perform at the same level as the state-of-the-art models that cost hundreds of millions of dollars to produce. And lastly, and perhaps the most surprisingly, is that you can actually run these on such little compute that it can even be run on a regular computer. Now, this last point is critical, and I'm going to go into that in just a second. Now, when this news hit the market, the response seemed kind of logical. The markets crashed because everyone said, okay, it's going to cost 90% less to use AI. And so therefore, people are going to spend 90% less on AI. And obviously, Nvidia, who are makers of these chips that are used to train the models and also, compute at inference, they thought, okay, well, Nvidia's value is going to go down because they're going to make 90% less revenue. But this is where they're wrong. This sort of thing has played out multiple times in history, and Wall Street often gets it wrong. So let's give a couple of examples. So back in the 1800s, a guy called William Jevons noticed something kind of counterintuitive about the coal markets. The more that coal price came down, people thought that that would reduce the overall demand for it. But actually what happened is prices came down and people found more ways to use coal. And so overall, the aggregate demand increased. And this is known as the Jevons paradox. So why does this happen? Well, effectively, when something becomes cheaper, people find more and more ways to use it. So coal got cheaper, so it was used in more things and it became more accessible. And the same thing is happening with AI. Now, if AI gets cheaper, we can use it to do more and more things. And that's ultimately going to raise demand over the long term. So let's give an example. Right now, if something costs $100 to do, then the kind of cost or the return on investment of that needs to be about $100. So you could use AI for all sorts of use cases, but because the cost of it is at a certain price, it wouldn't make viable sense to use AI unless you could charge that much in return. If we bring the cost of AI next to zero, we can basically put AI into everything in our daily lives and improve things even in the smallest marginal way possible. Now, if this happens, we're going to find lots and lots of innovative ways to use AI throughout all of the industry, all different kind of sectors, all kind of different jobs, all kind of different use cases. And the net result of that is it's going to introduce AI to more of humanity and overall demand is going to increase. So everyone that is short in Nvidia stock right now might want to think twice, because in the long term, the demand for Nvidia chips is just going to go up. Yes, you might be able to produce a lot more for 90% less cost, but that doesn't mean that the overall demand is going to go down. It just means that what we're going to be able to do with that same amount of money is going to be 10x more than what we could do today. So the best part of all of this is DeepSeek have open sourced the model. So to understand what this is, firstly, most companies generally build things behind closed doors. If you want to access a product, you've got to pay for it, and everything, all that kind of data and technology is proprietary and private, and you don't know what's happening. Now, a lot of people are worried about DeepSeek because it's a Chinese project. So people are worried about censorship, people are worried about capturing people's data. Is it a security threat to the US, and so on and so forth? But actually, this company have shared all of the code behind the scenes. And this is what it means by open source. So you can actually take all of that code and you can put it onto your own computer and host it with your own servers and basically just run it yourself. That means that you don't have to pay for the cost of the APIs if you were to plug into DeepSeek and their product. And it also means that you don't give China any of your data. So this is a huge gift to the community because we can all take these. We can now learn exactly what happened. So what's going to happen with these companies like OpenAI and Anthropic? They will take all of these techniques that have been discussed in these open source papers and the open source code. They're going to adopt it themselves, and we're going to see the cost of advanced AI reduce massively. So this is not a bad thing for the AI industry whatsoever. It might be bad if you are building models because there is a lot more competition, but this is where it gets really exciting for people that are either building AI applications or the consumer, because we benefit the most. We're going to have an explosion of products that are much cheaper to run, with founders creating companies for much more niche projects and use cases. This is going to be an absolute Cambrian explosion of innovation, and we're very, very grateful for it. So that in a nutshell is what has happened with DeepSeek. And if you like this video, think about giving it a thumbs up and subscribing. With that, thanks very much. See you in the next one.